External high performance storage, Oyen Digital MiniPro RAID version 3. And this is the second one of these devices we've looked at. The first video we did, which was supposed to be about this one, was about troubleshooting. So we're going to go through this and let you guys see this and hope this one's going to work. I'll get into the specs once we get into this. We've got an unboxing, inspection, installation, and test to do, and I'm going to get to that test. The first thing we're dealing with is portable storage. We've got two SSDs in here, and the technology is well matched for the connection speed. And what we want to do is test this and make sure, as we do this unboxing, that we have what we think we've ordered. And I want to thank Bob for making this video possible. MiniPro high performance storage solution. Now the other one was in a bag. This one is in a box. And the labeling is correct. Oyen Digital MiniPro RAID version 3, 16 terabyte. Again, to reiterate, two drives in here. And we're going to see a front and a back. And we're going to go through the configuration very quickly, but we need to check our components. Now, this is 10 gigabit USB-C, and there are actually 4 modes of operation. We're only going to focus on 3. One of them doesn't matter, but I'll get to it as we read the specs. The first one is default, and that's JBOD. Then it does RAID 0 and RAID 1. Bus powered or AC adapter. We're going to use the AC adapter. Aluminum housing. It's passive cooling. Easy setup, no software. To reiterate, this is a hardware RAID solution. And we have a factory seal, which we had on the other one, but it didn't make any difference. It didn't work. So we're going to test this in the default configuration. And we want to verify this thing works. And that was a problem we had with the other one with the troubleshooting. Okay, literature. Thank you for your purchase. A manual with the contents. We'll go through that. That information is also in the PDF file that we'll bring up on screen in a little bit. The device itself. Oyen Digital MiniPro RAID. In a bag, it's sealed. And we know factory sealed. We think the other one had a problem with a manufacturing defect, but we don't know. With all the testing we went through, we'll know real quick if we're in business or not. We'll set that aside. Now for the other parts. There's a screwdriver, a really nice Phillips, non-magnetic. We have 2 USB cables, one for USB 3 and the other is for USB-C to USB-C. And then, of course, our power tap. Nice thing about the screwdriver is if you need to service it in the field, you can. They provided a screwdriver for that. Hopefully there won't be any issues this time. We're going to find out. But if we have to open it up, we'll open it up. And what happened was, and I'll show you on their website, they've got 3 tests. There should have been 4. When you're in JBOD, you've got 2 drives. That's just a bunch of disks. So they tested drive 1. They didn't test drive 2. When we tested drive 2, things went flat. Or I should say things went south from there. We're going to be plugging this into a USB connection for the test, and then we're going to turn around, plug it into a Thunderbolt 3 port, and verify that information. Make sure we have connectivity. But connectivity is only the first part. The actual throughput is the part that I'm interested and concerned about. Bob said, well, if it only does 80%, I said, Bob, this thing needs to function as it's designed, as it's intended, as it's sold. If it doesn't, it's no good. High performance storage. And again, to reiterate, the technology for the interface is well matched to the speed of the drives, whether they are in JBOD or RAID. We'll get into all that. We'll set the screwdriver to the side, the thank you card in the manual. Now, if we had drawn power from the bus, I could see where that might have been a problem, but that's why we're going to use the wall wart to draw power. We have control lights on the front that I'll get into, and we also have controls on the back that we need to take a look at. And I'll bring up the information on the manual and go through all this and zoom in on it. But right now, we want to get this plugged in. And I'm also going to bring up, when we do our heat and speed test, to test this, I'll bring up a picture-in-picture so when I'm plugging this in, you can see what's going on while you're watching what's going on the screen, so you understand the connectivity. First things first, the power tap. We'll take a look at the default mode. And we're going to go over to Oyen Digital's website. 3 different configurations, hard drive, solid state, and the enclosure only. The version we have is the solid state, and we have the 16 terabyte. That's the most efficient. Now I'm going to scroll down below overview, configurable for JBOD, RAID 0, RAID 1, and big mode. I would not use big mode. JBOD is the default. Let's take a look at the specs. 16 terabyte. We know we have 2 Samsung drives, USB-C 10 gigabit. We know the chipset, AS Media. This supports UASP and trim. That's a big deal. And here's the 3 tests, JBOD, RAID 0, and RAID 1. To reiterate, they've only got 1 JBOD. And since there's 2 drives, we need to have 2 JBOD tests, drive 1 and drive 2. So let's plug it in. First thing, I'll treat it like a camera. I'll plug in the wall wart first. And this cable is a little bit short, so now we're going to plug in power to the device. And then I'm going to spin this around. When I plug this in, I'm going to put a camera on it so you can see what's going on. I think this instruction sheet that they included, which I appreciate, is a lot easier to read from the PDF file. And that gives us a chance to look at the front and the back of what we're going to see. Now there's going to be a power LED on the left side. Once we apply power to it, this light will come on. These lights for D1 and D2 will not come on until we have connectivity with the computer. So I'm going to put this on another camera. There's a power button on the back. Power tap here. This is the button for reset. These are the switches for changing the configuration of the device. And it's set for DC or USB. And that's interesting. We're going to switch that over for DC. And there's our USB-C connection, 10 gigabit. I point that out because we're working on another video about 20 gigabit USB-C, so something you can expect, different video, but 20 gigabit. I'm going to plug this in, but I want to show you from this side. And to reiterate, we're going to see a light right down here on the left side. 2 lights for D1, D2. I'll plug it in, and when I turn it on, you can see the light come on in there. It's a little hard to see, but it's there. And these other 2 will connect once I plug in the cable. Even has a cable tie on the cable, which is nice. So that's the USB-C cable. Fairly good sized cable. We'll plug in the back. We have connectivity. What I really need is a camera on both sides, but this works. Spin it back around so we can see the lights on the front once we plug it in. Now we're going to plug it into the USB-C port. So what you're going to see is me plugging this in on the desktop in the background as this device enumerates. Plugged in, and we have a couple of windows that popped up showing the drives are active. And you can see these 2 LEDs. These are a real bright blue. On camera they look white. Look like a white LED like this, but they're actually a bright blue. I'll take that screen off. And that's the desktop computer. Now these drives already have labels on them, which is interesting. The names are different than they were last time. D2 and D1. So a different manufacturing process is my guess. I'm going to close both of these. We're going to go to the Windows Flag E, this PC, and that's the other view of those 2 drives. So I'm going to right click on the first one, Properties, and I want to check how this drive is set up, exFAT, which is the preference of Microsoft for external portable storage, and format it out, 8 terabytes, 7.27 terabytes. So to reiterate, we have 2 8 terabyte drives. We're in JBOD, and what we're going to do is test these 2 drives, number 1 and number 2, compare the results with the results that we're getting with the JBOD from the default from Oyen Digital, and we're going to compare that, what we've seen with their results, with our results, but on both drives, not just one. Hopefully, this one's going to work. The other one, you guys didn't get to see. All you saw was the troubleshooting. I learned a lot about the device. I knew I learned enough that I like the device. I like the technology and the way it's designed, but I think there was a manufacturing defect. I don't know if it was the SSD or if it was the circuit board or if it had something to do with the chipset, the AS media. I don't know. But I'm seeing different information on this and based on drive labels. I'm very aware of the details on this. We had 3 days working on the other one. So let's get to our heat and speed test to get those numbers up. Close that window. Close that window. We're going to bring up hardware info. And what we want to see are the sensors only, because we have smart telemetry that passes through the chipset. And in this configuration, we should be able to see both drives. We've got to scroll down now and find the drives. And we're looking for Samsung. The first drive we see is the boot drive in the computer, which is the Seagate Fire CUDA. And that's a 520. I believe, somebody correct me if I'm wrong, that's PCI Express 4 first generation, which is about a 5,000 megabyte drive, which will be an influence on our test. Not this test, this is the first test, because when we're talking about specs, there's an issue of, and we're going to get into that in another video, but there's an issue of burst mode versus throughput. So when we're talking about bandwidth, this test we're getting ready to do is about burst mode. I'll do another test which is relevant to how fast the other drives are going when we do an actual throughput test, where I'll copy some video from that Seagate Fire CUDA 520 over to those SSDs. I'll do the same thing to both of them. So that way we're not pulling data from a spinning drive. We're pulling it from an PCI Express 4.0 M.2 NVMe drive, which is sufficiently fast to tell us what we're going to get here. And we have a pretty good idea of what we're going to get based on these numbers, which should be true to this drive, but let's see, based on the spec. So there's the first drive, the Samsung, and I'll zoom in on it so you can see it and read it right quick. So we're going to be looking at minimum, maximum, and average, and there's the second drive that we'll also then repeat the test for. So we have to zoom out, and I want to be able to see the Seagate with these other two. Now we're going to bring up Crystal Disk Mark, and we have to remember, we'll go to the D drive first, which is an 8 terabyte drive, so we want an 8 gigabyte test file. That should clear the cache. We'll keep these two side by side, let the test complete, and then we'll do the second test. Start. Just real quick, when there's activity on the drive, the lights will be blinking. When there's no activity, they're solid. And the test is complete, and I am quite pleased with those results. To reiterate, remember this is a burst mode test. So on our read, we're 567 megabytes versus 555 megabytes. And on our write, we're 532 megabytes versus 285 megabytes. I think the point and distinction needs to be made clear on this. This is a hypothesis, but based on the results that Oyen Digital themselves are showing for that first device are similar to what we had on the first device. This is the second device, and our results are more acceptable and more respectable in respect for relations for the drive that's in the container. So Oyen Digital needs to rerun that test. That's drive 1. We've still got drive 2 to do, but I find that fascinating and interesting. That tells me that there was a problem, something with the manufacturing, that I don't think somebody caught in quality control. I guess that's what we're here for. So let's see what the next drive does. And while we're at it right quick, we can take a look at our temps because those are still up. I'll zoom in on that. Our minimum was 33 degrees and our max came to 39 degrees Celsius. That's acceptable within those parameters. And for those that are asking, there is only one thermistor on that SSD. I have to be careful with my terminology because I'm so used to testing M.2 NVMe SSDs, and this is just a straight 2.5-inch SSD. Now for the next test. We're going to go to drive F to reiterate same capacity, 8 terabytes with an 8 gigabyte test file. We will highlight and watch those numbers, and let's press all and see how that compares. Drive F, all. Highlight. This drive started off at 32, right now it's at 35. We'll see if it goes to 39 as well. And just a quick peek, those drive lights are getting busy, so you can see there's activity. And JBOD test number 2 is complete. Whoops. Yep, okay, this time it deleted the cache file. The device popped up with the drive and the cache file. Last time, the device hung, and because it was hanging, the cache file stayed because it did not finish the render, because after the render for the test, for the speed test, that file stayed there. This time it deleted it, but we got to see it. All these little details matter. Now, for those that are asking about the troubleshooting video, please watch it. And to have taken that a step further would have been something we could have observed further, but it's not something we could have fixed any further. In other words, we could have taken the two drives and swapped them, but if the problem exists because of the PCB with either the firmware on the chip or the chip itself or some of the logic on that board, no amount of monkeying with it would have solved that. So what I'm seeing now is working, and that's positive. So I'm going to close these two windows of the drives. Let's zoom in and look at our results. 567 megabytes on the read and 406 megabytes on the write. Not as good as I'd like, however, compared to those results of 555 versus 567, and then the Oyen Digital results of 285 versus our 406, that's a big difference. That's acceptable. So now that's two tests. That's JBOD, drive 1, drive 2. To reiterate, I think Oyen Digital needs to rerun the test, and I think they need to double check their quality, which apparently they've done with this drive. So two drives are working. Now we're going to take them, put them together, and we'll do RAID 0. And before we get to that, let's double check our heat. On this one, the drive got just a little bit hotter. We started out at 32 versus 33, and we finished up at 41 versus 39. So that's still acceptable. I just want to document all that as we go. So we're going to close all this down. Now the next thing we're going to do, we're going to look at the device based on the jumpers and what has to be done on the back, change the configuration, and then we'll look at the manual that tells us how to do that. Pretty simple. Now on this manual, we're going to go through system setup. This default, to reiterate, is JBOD, 2 independent drives. The MiniPro RAID version 3 has pre-installed drives, affirmative, formatted as exFAT, affirmative, and those settings will work for a Windows PC or a Mac PC. Now, if you desire a mode other than JBOD, perform a set RAID, and that's what we're going to do. And we need to set the switches to the desired mode. And those switches, of course, being the switches on the back of the unit. So we're going to spin that around, see if we can get the camera on that. First thing we want to do is turn the unit off, and I'll disconnect from the computer. Our 2 switches are in the up position. We're going to go to RAID 0, which has them in the down position. So we'll set those 1, 2. The next, number 2, connect the MiniPro RAID to the host computer and turn on. So we'll connect to the computer on USB-C, come back up here and turn on. And if we spin this around, we have a power light here on the circuit board, you can see, but we don't have connectivity here yet. We'll spin it back around. Now we have lights. And as you can see, picture in picture, the 2 drives are showing up. I'll close both those windows. We'll go back to the manual. Number 3, using the tip of the screwdriver, press the set button for 5 seconds. Number 4, release the set button. The RAID is configured and ready for formatting. So we'll spin it around to the set button. 1001, 1002, 1003, 1004, 1005. And spin it back around. We've got lights, power light and 2 drive lights, so we have connectivity. Next step, if changing or deleting a RAID mode, perform a clear procedure. So we're going to go to section 6, formatting the drives. After setting a new RAID mode, you must format the volume, which is done by the operating system. Remember, this is an external hardware RAID. RAID 0/1 or span will appear as a single drive. So going over to the computer, we'll go to Control Panel, Administrative Tools, Computer Management, and then over here I'm going to click on Disk Management. And the dialog box will probably pop up, which it does, and it says you must initialize a disk before Logical Disk Manager can access it. It sees disk 1, which is to reiterate 2 drives. We're going to set it for a GPT versus the MBR. That's for a topic of discussion for a different video. And we'll say OK. And this is that drive that'll format 16 terabytes out at about 14.9. Pretty good. Depends on how you count your bits and bytes. And it says the drive is online. So we're going to right click. Now you can, in this area on the left, you can click, right click. Or in this area where I'm highlighted, if you can notice that, and then right click, and then create simple volume. And that's what we want to do, and we're going to follow the wizard for the maximum capacity. We're going to go next, full capacity, next, a drive letter gets assigned, next, and what's important here, the default is NTFS. We're going to change that to exFAT. We're going to use the default allocation size, and this is where you'd want to set it according to the file sizes you're working with. And since Bob's going to be working with video, we're going to leave the default. New volume, we're going to call this OD for Oyen Digital, RAID 0. And we're going to do a quick format, otherwise we'd be here all day. Next, and that's the result of the wizard. Nothing happens until we click Finish, and we should see another box pop up showing the drives available. Finish, formatting, and voila, it's ready. I was trying to get this up quick enough to show you these lights. In other words, to reiterate, when there's activity, these lights are blinking so that you could see when those lights are on, but I wasn't fast enough, that we have the windows right there, or I say windows, singular, window. And it shows the label, OD RAID 0 for Oyen Digital, MiniPro RAID version 3. I'm going to close it and close all this information out. Then I'm going to go back to the device manager, which will be, then I'm going to go back to Windows Explorer, which is Windows flag E, this PC, and I don't need to go to device manager, just right there. OD RAID 0, that's our drive, and that's what we're going to test. And for those asking about capacity, that's the way things are counted, binary versus decimal. Separate topic, separate discussion, separate video. We'll close that. Now, for this RAID test, what I'm curious about, here's what we know to be true. Based on the specs, let's take a look. According to the AS Media chipset, and I'll have a link up to all this stuff in the video description, this supports UASP and supports trim. Okay, because this supports trim and passes that information to the chipset, what we know to be true, number one, is we have seen heat, which means we're reading the thermistors. And because we have smart technology reading that, because we have trim support, that means Windows will automatically if that's your operating system, manage that trim, nothing we need to do. I'll put up a link on how to figure out if that's turned on or not, but that should pass. Now, this chipset also has a firmware that should be upgradable, but I have not seen anything from Oyen Digital about that, so I don't know what the status of that is. That could have been the problem with the first drive. I don't know. I'm just thinking out loud. So what we want to find out is, will we still have this information where we can see the thermistor on those two drives? Let's take a look. So we're going to go to Hardware Info, Thermistors Only, or in this case Sensors, and let's see if we can see those drives. The AES Media chip says it'll pass it through. Well, there's the Smart on the Seagate, and there's the Smart on a Samsung, but I don't see the second drive. So that is a question that I would pose to Oyen Digital and ask about that capability being seen or not being seen. To reiterate, Smart is there, but we're not seeing it. We see one drive, and I suspect, I didn't check the serial number, but I suspect that's the first drive we're seeing. We're not seeing the other drive. Right now we're at 38 degrees, but I could be wrong on that. Somebody wants to check and verify, let us know. So I'm going to keep this up. Let's bring up Crystal Disk Mark, and this time we're looking at D drive, which is a 16 terabyte, so we need a 16 gigabyte test file. And let's see what kind of numbers we get. Now, before we start, right here with Oyen Digital, RAID 0, which would be one test, and then a RAID 1, one test. Let's see what they got. So those are the kind of numbers we're looking for. Hopefully something close to that, or maybe better. I think the main thing from this is to always test and verify, no matter what specs are, when you understand what your technology is you're working with, like 10 gigabit USB-C, and working with an SSD, which an SSD is a SATA 3 drive, which is a 600 megabyte burst mode. So the actual throughput just below that, plus the overhead for the interface, pretty good numbers. Let's see. All, and I'll highlight. So my only concern so far, from what I've seen, is yes, we have Smart, yes, we see trim, but we're only seeing one drive, the first drive. For some reason, we're not seeing the second drive. I'm not sure why that's not being passed through. So that would be a question I would ask Oyen Digital. What's up with that? Because if we don't see the second drive, we're not getting trim on the second drive. We're only getting trim on one. I would be concerned about that for the longevity of the drives. And the RAID 0 exFAT test is complete. 886 megabytes on the read and 881 megabytes on the write. And our temp, we went from 38 degrees minimum to 44 degrees maximum. Let's see how that compares. Their results are 814 megabytes on the read versus our 868 megabytes on the read. And Oyen Digital on the write, 862 megabytes, and we achieved 881 megabytes. Now, I call RAID 0 RAID by the seat of your pants because we got speed and we have capacity. The next test we need to do, and I like these numbers, this is so much different than last time. It took forever for those tests to complete on the other drive. There was just something wrong with it. But anyway, to reiterate, we're now ready to do the third test, which is actually number 4, because we've done the first two tests, which is JBOD on the first and second drive. We've now completed RAID 0 on the two drives. We now need to go and reset this thing and do RAID 1. But I'm very pleased with those numbers. So we're going to close that out. We'll go back to the manual. And the RAID modes, RAID 0, which we've done, JBOD, which was the default. We're now going to do RAID 1, which is mirroring. Two drives, and this is a point I think that needs to be made to reiterate. What are the requirements for RAID 0 and RAID 1? Two drives. Two drives are what we have. That's what we can do. And JBOD, always you have to read the description of whoever's talking about JBOD, because there's a JBOD in RAID, which is just a bunch of disks, but some refer to JBOD as combining, which is what the other mode is, the I'll call it the fourth mode they have, which I wouldn't use, which is what I would define as concatenation, where you write to one drive and then write to the other one, which is kind of a failover. But if there's any issues with the addressing of that drive going from 1 to 2, you could lose your data, so I wouldn't use that big mode. And I mention that because the SSD recorder that we use, which is rack mount from Blackmagic, has the ability to record to two SSDs. It doesn't record to them both. It records to one disk, and then it will start recording to the second disk, because it has the ability to cut it off and start the next one without losing anything. But to reiterate, on this, I wouldn't do that. So we had JBOD mode, RAID 0, now RAID 1. And the speed is slower in comparison to RAID 0. However, if one drive fails, no data is lost. You simply replace the failed drive, back up in business, and away we go. So this brings up a question: how large of a drive will this thing handle? Based on Oyen Digital specs and based on the chipset that's in there, we're good for up to 8 terabytes. And retail right now, that is the largest SSD that's available. There are larger, there will be larger later, but different interface, separate topic. To reiterate, 8 terabytes. Now, based on the AS Media chipset, which also says 8 terabytes, and based on the technology that we're aware of in the past, I don't think there's going to be any additional problems addressing a larger capacity based on what we're currently doing. So this should support a larger drives, but both drives need to be the same size. Preferably same brand, same drive, capacity, performance characteristics, so one drive doesn't pull the other drive down. And if you have two drives of different sizes, what will happen was when they're set up, and I wouldn't do this, but it'll go to the lower capacity drive. In other words, the chain is only as strong as its weakest link. So if you put in like a 8 terabyte and a 4 terabyte, then you're going to end up with two 4 terabyte drives, which is 8 terabytes, which is a waste. So to reiterate, if you're going to swap out a drive, put the same thing back in there. And I'll have a link to that drive in the description. So back to RAID. This time we're going to go to RAID 1. So switch number 1 is down and switch number 2 is up. So we're going to turn the unit off. I'm going to go ahead and disconnect from the computer. And this time going in on those jumpers, switch number 2 up. So to set the RAID, number 1, we set the switches. Number 2, we connect to the host computer. Done. We want to turn it on. I'll turn it around. Device light is on. We want to see these two lights come on once we have connectivity. And then we'll reformat again. And there we have it. Device activity. I want you to see the lights this time. I was ready for it. Okay. One window. Drive light came up. But remember, now that we've connected to the computer and turned it on, we got to go through step number 3 using the tip of a screwdriver and press set for 5 seconds. So we'll spin it back around, and I'm going to close that window, get out the screwdriver, and reset. 1001, 1002, 1003, 1004, 1005. I'll spin it back around. You can see the drive lights, and you can see power. So we'll go back to the computer, again to control panel, administrative tools, again to computer management, and again back to disk management. Dialog box should pop up, and it did. Everything's behaving like it should. None of this went right last time. Okay, to reiterate, initialize. Disk 1, GPT, we're going to say OK, and it's going to show us, right here's the drive unallocated. If we do a left click on the left side and then right click, it shows us our options that we don't need to worry about. But then we will, on the right side, left click and then right click, and we'll do a new simple volume. And we're going to follow the wizard again. Next, full capacity, but this time our capacity, because we are combining the two disks, we are not in RAID 0, we are in RAID 1 for redundancy. So we'll click next, drive letter D, next, and again we're going to set this for exFAT, the preferred format, new volume. This time I'm going to call it OD RAID 1. We're going to do a quick format. I'm going to get this over on the side so you can see it, and I want you to be able to see the lights on the drive when we start the procedure. So I'll click on next. These are the results of our selections in the wizard. We're going to click finish, and that'll go from unallocated to allocated, and the drive should pop up. And you can see the drive letter. This takes a little bit of time, but just let it do its thing. Let it finish. And when it's done, another drive letter should pop up. And it did. There it is. I'll take the drive off. We'll see just the computer screen. And there's our drive letter right up here, showing it's functional and ready. OD RAID 1. So I'm going to close all that down. I don't need that stuff up anymore. I'll do Windows flag E, this PC, and right there's our drive, OD RAID 1. We'll right click on it, properties, and this tells us the drive is set for exFAT. The label is OD RAID 1, which I could change here if I chose to. Shows the capacity, which is two 8 terabyte drives in RAID 1. And that's a difference of decimal versus binary. So we'll click on cancel and close. Now let's go back to hardware info. I want to see the thermistor, which is going to be sensors only. And again, I'm curious to reiterate to see what we're going to see. Will we see two drives, or will it be like before with one drive? And again, to reiterate, I did not verify and check the serial number. All I know is I see one drive, which I expect is probably the first drive. I see the Seagate Firecuda Smart. I see the Samsung 870 Smart. And we're starting off at 41 degrees. So I'm curious to see where we'll end up. So let's bring up Crystal Disk Mark. And again, we're going to reiterate drive D. And this time we're at 8 terabyte. So we need to change the file size we're testing with back to 8 gigabyte. That should be enough to clear the cache. Now, before we start the test, what kind of numbers can we expect? Let's take a look. RAID 1. And that says 555 and 494. So let's test and verify. All. I'll highlight and we'll watch that temp. Now to reiterate, this is burst mode. And just a quick glance so you can see all that drive. It's getting busy. Again, we have the device connectivity, but we have drive activity here on the right, both drives. I'll remove that. We'll finish the test. And the test is complete. That took longer than expected. However, it did finish, but look at those numbers. I'm okay with the read, 568 megabytes on the read, but the write, that's terrible. That's pathetic. There's still something wrong. 162 megabytes on the write, and I know we're in RAID 1, but that's not acceptable. When you look at these numbers as tested from Oyen Digital, to reiterate, RAID 1, 555 megabytes on the read, as opposed to our 568 megabytes, and Oyen Digital on the writes has 494 megabytes, whereas on our writes we have 162 megabytes. For me, that's a problem. And checking our temps, this said this time we started out at 41 and finished up at 42. So I'm not quite sure what to make of it, although I do know, and some of you are going to ask, what about the other test for the throughput? I'll test throughput on this, but I needed to get to result because remember the first time we did this, to reiterate, 3 days. Whereas this right now, we're at about 2 hours. I needed to get through some of the tests to look and see if I found something where there was an anomaly. And we have it here. Now, Bob wants this device of the 3 modes, of which there are 4. He wants this in this mode, RAID 1. Okay, RAID 1 is about redundancy. So if something happens to one drive, you've got the other drive, your data's safe. Based on the way this is performing, I would not leave it that way if he keeps it. My suggestion is going to be to send it back. Now, granted, we need some interaction with Oyen Digital to find out what's going on, because this is crazy. This one performs better, but this does not perform as it should, as expected. To reiterate, what do we know to be true? We're getting trim support on one drive. We should see both drives. Now, when we talk about Intel RAID or AMD RAID, AMD, which is a software RAID, no trim. Intel only supports trim on RAID 0 under Intel RST. It is what it is. And if you go with a regular hardware RAID card like a Broadcom Mega RAID, trim passes through, and that's a different scenario. But for this, for an external portable storage, which is high performance storage, this device does not meet my expectations. So to reiterate, if he keeps it, I would keep it for RAID by the seat of your pants, which would be RAID 0, but I wouldn't keep it in RAID 1. I want to try the one more test. Let's check actual throughput, see what we get. So we'll close all that out. I'll bring up Windows Flag E, and we have some files up here that we've used in the past for testing with. And I'm going to take those 3 files, which were done with another device. These 2 capture files are from our SSD recorder. And this 3rd file is the edited file of those 2 files combined. So these are MOV files, and this edited file is an MP4. And the total capacity is 103 gigs. So I'm going to bring up another Windows Flag E, this PC, and we're going to go to our Oyen Digital MiniPro RAID, which is OD RAID 1. I'm now going to tab over, copy that material, and do a paste. And let's see how long it takes for that data to copy over. And that showed up at 149 megabytes, which is about the speed you could expect for a SATA device. But remember, this is SATA 3 SSD, so theoretically we're 600 megabytes. We should be able to get just under that, at least 500 megabytes. And 200 is the best I've seen. This says this is going to take 25 minutes to copy that amount of data. But now while that's running, a couple of other tests that could be run if those requirements needed to be met would be either the disk utilities from Blackmagic or AJ. They both have a disk utility that will tell you, and I believe they're both based on PCI Express 3, where they'll look at a disk and tell you what its capabilities are for the capacity. I don't think that test is relevant for what Bob's going to be doing, but I'll mention it in case somebody else is curious about it. I'm not going to run the test because I found the bottleneck, and I think Oyen Digital needs to address if that can be solved with a firmware update on the AS Media chipset. May not be the chipset. Could be some other logic that we're not aware of that they're not telling. Don't know. I don't think it's worth opening and looking. We have found that here's what we know to be true. Here's where we see a problem, and that's not a problem that we can solve. Can Oyen Digital solve that problem? Again, I like the device, I like the technology, I like the interface, I like the design, but we're just not getting the performance that we should. I'll take that window off so you can see just the disk. And all we're doing is copying data. We started at 25 minutes, we went down to 14 minutes, now it tells us 9 minutes. We are 40% complete, we're jumping back up, 200 megabytes. And we've been very specific and methodical in our approach so that if there's anything from Oyen Digital that said, did you do this or did you do that or did you try whatever, we can be very methodical that we followed directions explicitly. And that's why we did, because the details matter. That's still a throughput test of a specified size for a specified amount of time. 136 megabytes down to 48, and we've got 52%, 5 minutes left. 71% complete. Of the 3 configurations this could be purchased in, this is the way to go. If you bought just the device without drives in it, then if you had a problem, you're trying to figure out what's wrong with your drives. Having this pre-configured, it should be ready to go, which it is as far as being formatted, but if there's something wrong with the logic, there's not a thing we can do to fix that. And I would not put spinning drives in something like this. SSDs are ideal for this. Now we're back at 4 minutes, 30 seconds ETA. Just think about how so many people would buy something like this and not test and verify. Everything, always, you need to test and verify. See how it measures up. And always, your results may vary. You may get better results than we are. And we're doing these tests that I don't think I've mentioned yet on a high-end desktop, which is a Gigabyte TRX40 Designaire, down to 28 megabytes. Wow. 88% complete. I think my greatest concern, because it does not perform according to spec, is it has a greater opportunity or greater chance of failing. That's my concern. One drive receives trim, the other does not. I have a great concern over that. Let's think about this. USB-C can do 3 things, and we're doing one of those. One of those being data, the other being power delivery, and the third, if it's supported, is DisplayPort alternate mode, which is not part of this, but is part of USB-C 10 gigabit. Numbers are coming back up, 99%, ETA 5 seconds. We're down to less than 100 megabytes. Boom, done. I don't know about you, but that was kind of weird. Don't quite know what to make of it. Pleased in the fact that we're at 2 hours and 15 minutes, and we've achieved more in that time than I did in 3 days previously. But this is still just not up to spec. Let's look at that number again. So that's what we were supposed to get, and that's not what we achieved. So now I want to go through this, plug this into Thunderbolt, see what happens. So what we want to do is unplug that from USB-C, and when I do, those lights right there will go out. So I'm going to unplug it, lights will go out, power light stays on, and this time I'm going to go from USB-C over to Thunderbolt, Thunderbolt 3. We're going to go to port number 1, and I want to have the desktop up so we can see what happens. Drive lights are coming up, Thunderbolt control panel. Now we don't see anything here because it's not a Thunderbolt device. It's plugged into a Thunderbolt port. So what I'm going to do, you notice right here it shows the drive letter because that popped up. If I disconnect, that light will go out and that window will go away. I'm going to do that. Lights out, window's gone. I'll plug it back in, Thunderbolt 3. I get drive activity and boom. Look how quick that connects. And we're on a Thunderbolt port. So we would have 10 gigabit. So what I want to do is run the test again. Let's go to hardware info, sensors only. Let's scroll down to the smart technology. And this time we're passing this information. Yes, on USB-C, but through Thunderbolt 3. There's a Seagate FireCuda 520, and there's the smart on the one drive, the Samsung SSD, which is a Samsung 870, as defined in the specs from Oyen Digital Media. Let's bring up disk info, drive D, 8 terabyte, 8 gigabyte test file, and the numbers we're looking for to compare based on Oyen Digital or RAID 1, which is what we've just done. But that was on USB-C. It's time to distinction and to reiterate, Thunderbolt 3, USB-C. Let's see what happens. Nothing ventured, nothing gained. All. And for those curious, you can see those lights going pretty quick. I'll leave this on the drive. I want to show you the drive lights, but we'll leave this on the screen to see the results. Okay, test is complete. Our minimum temperature 49, our maximum temperature 53. And on our numbers, as we look and compare, I'm really disappointed. I like the read at 568 megabytes, but the write at 168 versus our 568 at 555 and their 494 versus our 168. So the only thing we did was we changed and we went to Thunderbolt 3. Something's not right. But I've seen enough to know that I'd like to know more information. I'd like to contact Oyen Digital. But in the greater scheme of things, based on the time frame Bob's got, and I want to thank Bob for making this video possible, my advice is going to be to send this back. Oyen Digital needs to test this. If there's a firmware update, I didn't see a link for it on their website. It's always anything's possible. So always test and verify. Your results may vary. I want to thank everybody for watching. Welcome. My name is Gil Boyd. This is BuildOrBuy. We look forward to seeing you in the next video. We're out.